The first part is just graphing. And so your first example is 3 times 2 to the x power. What's your starting value?
3.
3. And another word for starting value is the... Very good. So I go up 3. And guys, it doesn't have to be perfect, but up 3, I know it's really small. What am I doing with the 2? You're multiplying. So is it going to grow or decay? It's going to grow. It's going to get bigger. Exponentials make a curve. All right, exponentials make a curve. Okay? What about number 2? What is your starting value?
2.
All right, so I need to put a point on the y at 2. All right. This one is multiplying by 1/4. If you multiply something by 4, it's going to make it get smaller. This one is decreasing. It's called decay, and it is a curve. Okay? Exponentials make a curve when they are to the x power. It's exponential. Okay? If x was down low, it would be linear. What kind of graph does linear make? A straight line. Okay? All right, let's go ahead and jump over to this one on the side. Is 5 your y-intercept?
No.
No, very good. Why not? It has the x, okay? It's not your y-intercept. If I put parentheses, what number could I stick in front?
0.
A 1, okay? So 1 times 5 is 5, but 0 times 5 would turn it into 0. Right? 0 times 5 would be 0. Okay, so there's a 1 here because 1 times 5 would keep the 5 there. Okay, the 5 is supposed to be there. So my y-intercept is 1. What is my y-intercept?
1.
1. Okay, my y-intercept is 1. And is this one growth or decay? Growth. Okay, because you're multiplying by 5. That makes something bigger. So it's going to be growth. Okay, so it looks like that. Okay. All right, I'm going down to number 3. F of x equals 5, 3 to the x power. What is my y-intercept? 5. And this one is growth or decay? Growth. It's getting bigger. It's growing. Okay. It's a curve because it's exponential. Okay. Number 4, what's my y-intercept? 4. All right, 4 is my y-intercept, my starting value. If I multiply something by 2/3, smaller or bigger? Smaller. Is 2/3 less than 1 or bigger than 1? It's less than 1. So if it's less than 1, it's going to make it decrease. Okay? It's going to make it decay. All right? All right, what about this one? 1/3 to the x. What do I have to do? Good. Parentheses around it. And put a 1 in front. So my y-intercept is 1. Okay. Is 1/3 bigger than 1 or smaller than 1? Smaller, so it's going to make it decrease. Okay. It's going to make it decrease. Uh-huh.
So are you trying to hit like certain points and just like random?
I'm just sketching it. If you really wanted it to be exact, like for instance on number 1, we know that when x is 1, it'd be 2 to the first power, which is 2, times 3, you would get 6. So the next point would be 1, 6. All right, if you put in a 2 here, 2 squared is 4 times 3 is 12. Those would be your exact points, okay? All right, number 5, there's something extra happening. What's happening? Yeah, they're adding a number, and you'll do more of this in math too, but this moves it down 4. Basically, does 3 have an x with it? Does 3 have an x with it?
No.
No, okay. What about -4? Does it have an x? No. These two are going to affect your y-intercept because they don't have a variable with it. What is 3 minus 4? -1, okay? 3 minus 4, here's the 3, here's the -4, gives you -1. That is your y-intercept. So if they add an extra number, it affects your y-intercept. My y-intercept is -1. What is my y-intercept? -1. Then I look in the parentheses. It's multiplying by 2, so it's going to get bigger. It's going to be growth. Okay? It's going to be growth. Okay. All right, number 6, is my y-intercept 2? No. The y-intercept is 2 plus 3. Both of those affect your y-intercept. So 2 plus 3 is 5. So my y-intercept is 5. And if I multiply something by 1/4, it makes it smaller because it's less than 1. Makes it smaller. And it's a curve because it's exponential. Okay, Kaylin, did you get a sheet? Yeah. Okay. All right. Pick up where we are at, please. All right, number 7, a function is graphed below. What is the function? What's the y-intercept of that graph? Okay, the y-intercept is -3. Okay. All right, if I look at A, what's the y-intercept? Ooh, okay. We got to put parentheses. Got to put parentheses, and we have to put a 1 in front. We have to do that as our first step. You put a 1 in front, and then you do 1 minus 3. What is 1 minus 3? -2. Okay? So A has a y-intercept. A has a y-intercept of -2. So that doesn't work. Okay? Let's jump over to C. Put parentheses, put a 1 in front. 1 minus 3 is... All right, so that one also has a y-intercept of -2. So will C work? No. Okay. All right, for B, put your parentheses, put a 1 in front. What's 1 minus 4? So is that my answer? Yes, so B is the answer on that one. Okay. All right, number 8, what is the y-intercept of the graph of y equals 2, 6 to the x plus 5? What do I have to do on that one? I got to add 2 plus 5, which gives me 7. You add the ones that don't have x's. Okay? All right, number 9. Mrs. Hands buys a house for $150,000. The value of the house is expected to increase at a rate of 10% every year. Which graph best represents the value of the house after X years? Somebody raise your hand and tell me one that's wrong. Leah? Which one? D is wrong. Why? Good. This one is constant. It's linear. And this has a percent in it, so we know it has to be exponential, okay? Raise your hand if you can tell me one that is wrong. Owen? A. Why? Good. And the key word in this one is increase, so it's not A. Raise your hand if you can tell me another one that's wrong. AJ? C. Why? It's decreasing. So the answer is B, okay? All right. Number 10, which point approximately lies on the graph of the exponential equation with an initial value of 15 and a growth rate of 2.75%? Okay. This one you are allowed to use Desmos, and I'm just going to work it for you up on the board if you don't have a computer right now. But before I can use Desmos, what do I have to do? I have to do the y equals step, okay? I have to do the y equals, okay? What is my starting value? Good, because initial means starting, and that's the same thing. So y equals 15, parentheses, what do I put? 1 plus or 1 minus? Why is it plus? Because it says growth. Okay, so 1 plus 2.75? What is it? 0.0275. You move it 2 places, and this one has an empty spot, so you put a 0, okay, to the x power. Okay, all right, if you'll look up here, please, when I put it in Desmos, y equals 15, parentheses 1 plus 0.0275 to the x. And I'll zoom out. Okay, what does A say? 1.4125, is that gonna work? No. B says 331. So I can go to 3. Is 3 at 31? Nope. 5 and 50. Let's see if I can find 5. Is 5 at 50? 14 and 21. What do we think? Yes. So the answer is D. Yes, you could also do it on the calculator. Yes. Okay. Questions? All right. Exponential regression. The table below contains data from a study done on fungal growth. The fungal spores were studied over a period of several months. Based on the table, what is the initial number of spores? Okay. So let's go to stat in our calculator. I need everybody to do it. Go to stat in your calculator. Um, 2, 3, 4, 900, 2700, and 8100. Go to decimals. You don't have to. I was just going to show it. Yep. Start it. All right, right here where it says plus. Look, right here where it says plus. You have to choose a table to put it in. Okay. Okay, guys, real quick. Look up here, look up here, look up here. 900 to 2,700 goes up about 2,000, right? What about from 2,000 to 8,000? About up 6,000. Is this linear? No. Why is it not linear? It's not. It's not a constant rate. So this one, I'm going to say about 2,000, about 6,000. So it's not linear. What is it? All right, it's exponential. So in the calculator, I hit stat, over to calc. Exponential is 0. It's down to 0. Like you could just hit 0 and it would work. You're going to the one that says exponential regression. Okay? Press enter. Enter. All right. You should get that. Are you getting that? Okay, so I'm going to write down y equals, what is my starting value? 100. If it's exponential, I do parentheses. Even though the calculator doesn't have it, I put parentheses. What's going in the parentheses? No, the calculator, you don't have to move the decimal. It's already done it for you. So it's 100 parentheses 3. You don't have to move any decimals. The calculator's already done it all for you. Okay? What is the question asking? What is the initial number?
100.
Very good. The initial number is your starting value, which is 100. Okay. All right, now you come down here and you do y1, type y and a 1, and then you do this shift, this thing right here, and then you do a, b to the x1. And it gives you the 100 and the 3 like the calculator would have. It gives you the 100 and the 3. Okay. Oh, and if you'd rather do it that way, you can get a Chromebook. Number 12, treatment for feline hyperthyroidism involves a single dose of radioactive iodine. The amount of radioactive iodine remaining following treatment is shown in the table. About how much radioactivity will still remain 20 days after treatment. Okay, I'm putting this in stat. Okay, I'm putting it in stat. Zero, 8, 16, 3, 1.5.75. All right, is this linear or exponential? It's exponential. So I'm going to hit stat, over to calc, 0, enter, enter. Okay. The question's asking how much radioactivity will still remain after 20 days. All right, it's been a while since we've done this. I go to my y equals. Guys, do this with me, please. Go to your y equals. Clear out what's in there. Clear out. Then you hit vars down to 5 over to EQ, and you press enter. It puts it in there. Yours may look different than mine if your calculator's newer. Then you go to second window. Second window. You can only put in X value. So let's look and see. Was 20 days an X value? Yes. So you can put in 20 because it's an X. So you type in 20. And then what do you hit? Second graph. And what's the answer? C, 0.53. Okay. Anybody have a question? All right, go ahead and put 13 into stat. Okay, guys, look up here real quick. Two things. On the exam, remember the questions are going to be all mixed up. Some will be linear and some will be exponential. Some will be linear, some will be exponential. So, did this one say the word exponential? No. But I know if I look, this one went down by 300, down by 100 and something, down by 90, down by 40. This one is not linear because it's not constant, okay? So that's why I went to exponential, okay? The question's asking how much will there be after 2 hours? Is 2 hours an X? Is it a Y? Okay, so let's check. X just says interval. It doesn't say hours. Let's go back up and read in the question. Are they doing it in hour intervals? What are they doing it in? 20-minute intervals. So this means 0 minutes. This means what? 20 minutes. Mark this out, please. Write it down. 20 minutes. This means 40 minutes. This would be 1 hour. Okay. What would this one be? 1 hour and 20 minutes. So 5 would be what? 1 hour and 40 minutes. So if I get to 6, that would be what? 2 hours. So I'm looking for what it's going to be at what? 6. So when I go to second window, I type in, what am I typing in? 6. Second graph. And what is it at? Uh-oh. Does yours have the right answer?
Mine is 9.
Okay, hold on. 0, 1, 2, 3, 4, 600, 319, 162, 7. Oh, yeah. Okay, thank you, Corbin. Okay, so I forgot my steps. Stat, calc, exponential, enter, enter. I forgot to hit the y equals button. Clear, vars, 5, EQ. I forgot to do that step. Second window, 6, second graph. Okay, so what should it be? 9. Okay. Questions? All right. 14. A scientist conducts an experiment to observe the half-life period of radioactive element barium. He starts the observation with 200 grams of barium and records the mass at the end of every 13th day. After how many days is the mass of barium closest to 1.5 grams? Okay. All right, so let's put it in stat. right, is this one linear or exponential? Exponential. Okay, so stat, calc, exponential. Okay, I'm not gonna skip my steps. I'm gonna go to y equals. I'm gonna press clear. Then I'm gonna press vars 5 over to EQ. Okay. Are y'all with me or you need me to pause? Y'all good? All right, second window. Do I type in 1.5? No, 1.5 is a what value? Y. 1.5 is a y value. You cannot type in y values here. It won't work. We'll give you the wrong answer. What do we want to start at? 0, 1, doesn't matter. Okay, I'm going to say 0 just because that's what we've done in the past, whatever the table starts at. So 0. Second graph. Is 200 my answer? No, I have to scroll down till I find 1.5 in the y column. So I'm looking for 1.5 in the y column. Well, it's not A. We're getting close. Is it not B?
No. It's C.
Does your calculator go faster than mine? Yeah, this is a really old one, so I think that's why. Ooh, yeah, I forgot about that strategy. So Simone's saying if you go to second window, you could type in answer choice 13, because these are all X values, your answer choices. You could type in 13, then go look, is 13 giving you 1.5? No, then you could type in 65. Does that give you 1.5? Nope. And then you type in C, 91, and that one works. See, I told you this calculator's slow. Okay, so C. All right, last part. Average rate of change. What do I think of when I see rate of change? Slope. And what's the formula? So y equals mx plus b is the formula for slope? No. Very good, Camille. Y minus y over x minus x. What is this the formula for? A line. Okay? That's the formula for a line. We're not even doing lines today. We're doing exponential. Slope is y minus y over x minus x. Write it down. Y minus y over x minus x. Okay? Okay, so what is the approximate average rate of change for f of x equals 15, 1.5x from x equals 2 to x equals 5? What's the key word? Rate of change. So I'm doing y minus y over x minus x. Bunch of different ways to do it. I prefer to use my calculator, so I go to my y equals. I go to my y equals in the calculator and press clear. Again, there's multiple ways to do it, but I prefer this way. Then you're going to type in what is the y equals they give you. 15, parentheses, 1.5 to the x. So you remember you got to use your caret key right here to do the exponent, okay? So 15, 1.5 to the x, type it in. Okay, then go to second window. And what's the first x that they give you? 2. So second window, you type in 2, second graph. Okay. Here's what I'm going to do, and I highly recommend you to do this. I'm going to go ahead and make a little chart. 2 gives me, did y'all get 33.75? Yeah. Okay, so 2 gives me 33.75. I highly recommend writing this down. 2 gives me 33.75. What is the other x value they want you to look at? 5. So if you go down to 5, then you have 113.91. Okay, so when x is 2, I get 33.75. When x is 5, I get 113.91. Now I have to take these numbers and put them into the... No? The formula, okay? 33.75 minus 113.91. Those are my y's. Charles, you could put them in stat actually and get your slope that way too. You're right. So 33.75 minus 113.91. And then what would go on the bottom? 2 minus 5. If you put it in your calculator, you have to put parentheses around the whole thing. So I'm going to go to second quit, parentheses 33.75 minus 113.91 divided by parentheses 2 minus 5. All right. What do we get? 26.72, which rounds to 27. Is that working for y'all?
No.
Coach, please help. And I, we look at our calculator. All right, last one. The population growth for a species of birds in thousands can be represented by the function P of t equals 20, 1.24 to the t, where t is the number of years since 2002. What is the approximate average rate of change of the population between the years 2004 and 2007? What's the key word? Good, rate of change. What's the formula for that? Y minus y over x minus x, okay? All right, what are we gonna do first? Plug it in where? The y equals 20 parentheses 1.24 to the x. You're using an x, not a t. 20, 1.24 to the x. Okay, this one has an extra trick to it. It says t is the number of years since what? 2002. So 2004, it's only been 2 years. Mark that out and make it a 2. Mark that out and make it a 2. What about in 2007? It's been 5 years, okay? So you're actually going from 2 to 5 again. So second window, it's already at 2. Second graph, and I'm gonna go ahead and make my table. So 2 is 30.752. And what do y'all get for 5? Okay. All right, and after I get those numbers, I do y minus y over x minus x. Has anybody already done it? What you got?
A.
Anybody second that? Anybody getting an A?
Yes.
All right, good. See you after lunch.